Hello everyone, I'm Hong Bin Zhong. We are from National Central University, Department of Optics and Photonics. I'm going to present you our recent study on vehicle inertial navigation system, especially in fiber optic gyroscope. There are two different gyroscopes are already be deployed to different applications. First one is the standard MEMS gyro, which is based on the semiconductor technology. You can find the MEMS gyro in your cell phone. Another is fiber optic gyroscope, as known as FOG, which is already be deployed to the military and the industrial application. So if she want to choose one gyro for the vehicle navigation application, in MEMS, she will consider the accuracy, the tolerance of environment, or the reliability of the MEMS gyro. However, on the other hand, if she chooses the FOG, maybe she will think about the FOG maybe is too expensive, which per axis is around 10,000 US dollars, or is a bulky and heavy devices. So, since 3 years ago, based on principle of fiber optic gyroscope, there are the 5 major components. The first one is the sensing part. It's shown on the right-hand side of the slide, which is a fiber coil. Based on the Sagnac effect, show us the right corner of the slide. Based on Sagnac effect, if we rotate the sensing part, we will introduce a phase difference of this sensing coil. And we can use the multifunction integration optical circuit to modulate and demodulate this signal, and use the logic center to calculate the rotation of this sensor. So based on these 5 major parts, we reconstruct our FOG to produce a cost-effective solution. Our FOG, you can see the picture here. There is a 4-axis FOG in the sense and the size around the baseball. There are 5 parts, which is we miniaturize the sensing coil and let the compact and MIOC to be miniaturized. And then we use the mini logic center to calculate the rotation speed. The right-hand side shows the mini 1S, this PIG. The PIG, which is a positioning integration gyroscope. This PIG, in compared with the standard, the first generation gyro, we call the Sparrow. The Sparrow in the diameter is around 90 millimeter long, but the second generation PIGs only have length of 45 millimeter in diameter, which is a little larger than the 50 NTD coin. So the first result of the big one, which is Sparrow. The first sensing is 2 years ago. We can see the right-hand side of the slide. We can reach 7.2 degree per hour resolution of our first sensing. We use the Sparrow as a bigger one FOG to compare and combine with the 3-axis MEMS gyro and the 3-axis accelerometer, and with logic center and detector. So we construct the prototype of IMU, which is inertial measurement unit, for the road test. And we use 2 reference systems. One is reference FOG by commercial product. Another is a GPS V-bus for the reference. We test this IMU prototype on the freeway in the Feng-Bi-Wei tunnel. This tunnel is located in the north of the Taiwan island. This IMU provides different output with the fiber-based optical gyroscope output as a Sparrow and the reference gyroscope rotation data, and the oscillator data is provided by the MEMS oscillator. Another, we compare the GPS data to compare the precision of each module provided. This Feng-Bi-Wei tunnel is 2.25 kilometers long. We start the measurement from the Nanliao. So there are different curves shows different module output. the light yellow curve shows the main result of the IMU system. You can see it's already deviated around 4 kilometers since from the Nanyang. However, you can see the black curve, which is provided by the GPS V-bus signal. Because in the tunnel, they are without a GPS satellite signal, the position and the orientation will drift after the vehicle into the tunnel. However, the red and the blue curve shows our result of Sparrow FOG and the reference FOG, which get 1.1% deviation, another is 0.9 deviation in the Fongbyway tunnel. So which shows our prototype of Sparrow base, the IMU result. Since we provide a cost-effective fiber optic gyroscope, so there are several potential PIGs can be applied from the vehicle or UAV, or even in the underwater UUV, underwater vehicle. It can be also applied to the stabilizer for the camera or even for the sport. Because the PIG can mention the tiny rotation to applicate in different areas. So there it shows a picture of our PIG in the middle of this slide. And the left-hand side shows the IMU of the prototype. If you have any question or idea, please contact with us according to this email. Thank you.